Hey guys, so today what we're going to do is we're going to talk about the indefinite integral, which means we're going to start looking at our antiderivatives. We've been doing derivatives up through chapter 4. Now we're basically going to take and go backwards. So given the derivative, now we're going to have to be able to go backwards and figure out what function did that derivative come from. So let's just start with some vocabulary. So we have a function f, and it is called an antiderivative of a function. F on an open interval. So f prime of x is equal to f of x for all x in that interval. So here's our theorem. If f of x is any antiderivative of f of x on an open interval, then for any constant c, the function f of x plus c is also an antiderivative on that interval. Moreover, each derivative of f of x on the interval can be expressed in the form of f of x plus c by choosing the constant c appropriately. Now, the reason why we're doing the antiderivative, as you know, when you take the derivative of any constant is 0. So when we go to integrate or to find the antiderivative, we have to write a plus c because remember that c gets dropped when you are taking the derivative because the derivative of a constant is 0. So the process of finding the antiderivative is called antidifferentiation or integration. So again, what we're doing, again, as you know, we take the derivative of f of x. That is our f of x. Then integrating or antidifferentiating the function f of x produces an antiderivative of the form f of x plus c. We can use their integral notation. So this is our integrand symbol. The integral of f of x plus dx is equal to f of x plus c. So this is what the derivative is. So in other words, basically what we're doing is we're given this derivative, f of x is our derivative. By integrating it, we'll be able to now find the function where that derivative came from. Again, c is understood to represent an arbitrary constant. It is important to note that 1 and 2 are just different notations to express the same fact. So for example, if I integrate x squared dx, that gives me 1/3 x to the third plus c. That's also equivalent to this particular notation. So both of these, again, we're taking the derivative of 1/3 x to the third plus c. Notice that also results in the x squared. The adjective indefinite emphasizes the result of antidifferentiation is a generic function. The elongated s, which is the symbol right here, is the integral sign. The function f of x is the integrand. The c is the constant of integration. Again, if an independent variable is used other than x, then the notation may be adjusted. Again, if you have an independent variable t, a theta, or u. So again, may not always be dealing with x's. For simplicity, the dx is sometimes absorbed into the integrand. For example, if you're trying to just integrate plain old 1 dx, you'll just see the integral of dx. Or if you have a fraction and the numerator is a 1, you may just see the dx divided by x squared.